All right, today we're going to review the tangent lines, chords, and inscribed angles worksheet. There's a lot of problems, but I think after today you'll get the idea of what you need to do. All right, so on this first problem here, we have a tangent with a radius, and we know from our theorems that it's going to make a 90-degree angle. So because that's true, we have a right triangle. So we're going to use Pythagorean theorem to solve that, and when you're all said and done, you should get 7.5. So again, here's the 90-degree angle. Here is our hypotenuse. All right, if we go over to number 6, this length here is going to be 2.5. Most people understand that. Most people understand that that's going to be our x, but they have trouble trying to find that other side. And the reason they give us this 1.5 is because that's the radius, and so this must be 1.5 as well. So we can set up our equation, and again, our tangent and our radius are here. So we have x squared plus 1.5 squared equals 2.5 squared. And then when we're all said and done, we're going to get x is equal to 2. All right, coming on to number 7. Again, this is pretty easy. We have 12 squared plus 16 squared. And go ahead and do Pythagorean theorem. So that one's a pretty easy one there. In this example here, they give you the radius, which this is going to be your other radius. And then we have our 90-degree angle. And so we can set up our equation that way. So those are some of the questions where you have to find the segment using Pythagorean theorem based on the radius and a tangent line being perpendicular. All right, so let's take a look at the next set of problems here. All right, we want to find the perimeter, and this came from the theorem that said if you have two tangent lines to a circle, the two lengths of those tangents are going to be congruent. So this is 10.5, this has to be 10.5. If this is 11.2, this is going to be 11.2. Now we have the whole length being 23.2, so if we subtract that, we end up getting a length of 12, and that makes this length 12 here. And so we would get a complete perimeter of 67.4. So that's how we pretty much do these. You match the small with the other side. And in the case where you have the whole length, you take the whole minus the part to get the missing part, like we're going to see over here. So for example, we have 13 here. We know this has to be 13. The whole thing is 25, which makes this part right here 12. If that's 12, this becomes 12. We subtract 12 here, and we get 9.8. And we work our way around, and you should get an answer of 78.8 when you work your way all the way around. All right, similar down here, if this is 14, this has to be 14. And then this has to be 9, 9, and then you work your way around this, and you get a total answer of 73.4. Okay. The answer to this one using the same types of strategies is going to be 77.8. So there's the answers to the perimeter questions. All right, next, let's take a look and see what we have. Okay, so they want you to find the measure indicated. So they want this angle here, where earlier we talked about the radius and the tangent being 90 degrees. This triangle right here is an isosceles triangle. So if this is 63, that has to be 63 as well. So if we add that up and subtract from 180, we get a total angle of 54. And again, earlier we talked about how this was 90. So now we have 90 and 54, right? Which is 144, and we can subtract and get 136 for that angle right there. All right, over here, same thing. We have, here is our isosceles triangle. So we know that if this is 90, which it is because we have a radius and a tangent, and 44, right, that this angle here is going to be 46, this angle will be 46, which makes this angle here 88. Again, how do we get 46 here? We have 180, the whole thing. We subtract 90, and we subtract 44, and that leaves us with 46, and then we can use the isosceles triangle to go from there. All right, in this problem here, we had the rule that these are 90s, so the shortcut was both of these had to add up to 180, which gives us an answer of 63 degrees. All right, over here, this is 90 and 52. that makes this thing 38, which makes this angle 38 because there's our isosceles triangle, and then that makes that 104 degrees right there, okay? So that's pretty much the problems that look like that. So let's see what we have next. All right, so now we're talking about lengths of chords. And the one thing we need to know about lengths of chords is if there's a perpendicular line, then it's bisected. So in this case here, this has to be 6 because it's bisected this way. So there's really nothing else to do on this problem. If we look over here, this is perpendicular to the chord. If this is 3, then that has to be 3 as well. All right, if we come over this way, this is 31.8, which makes the radius 15.9, which means this is also the radius at 15.9. And if we subtract 7 from it, we get a value of 8.9 right there for this part right here. All right, if we come over this way, the radius again is 9.7. So we know this has to be 9.7 as well. Out of 9.7, we have 5.1, which leaves us with 4.6 units long there. Okay. All right, we have a couple more here we'll take a look at. All right, over here, so again, 25.2, that's going to give us a radius of 12.6. There's our radius of 12.6. We have 4.5 there, which leaves us a total value of 8.1. So combined, those two are going to be the same. All right, over here, same thing. We have our radius of 9.4, we have 4.2, which leaves us with a value of 5.2 here. Okay. All right, a couple more. So far the math on that has been pretty easy. All right, they want you to find the radius in this problem. So, and they tell you that this is 10.4 and that's 4.3 and 10.6. So we're gonna do Pythagorean theorem because this is gonna be the same as this. So we have 4.3 squared plus 10.6 squared, and we're gonna end up with 11.4 when we're done. All right, number 8. Same thing, if this is x, this will be our x. We have our Pythagorean theorem. It'll be done very much like the other problem, and your answer will be 9.4. All right, over here we have 8.4 and 10.4, so they want you to find this value. All right, this one's gonna be done a little bit differently, where we set it up that way and subtract it, and you should get a value of x equaling to 6.1. All right, over here, they want you to find x, they give you this. They tell you this is 10.8, which this also has to be 10.8 because a chord is going to be bisected when there's a perpendicular diameter or radius going through it. And when we're all said and done, you're gonna end up getting 6.3. You would have 12.5 squared equals to x squared plus 10.8 squared. And then use Pythagorean theorem to figure out the missing values. Okay. All right, here, if this is 16.7, this is 15, they want you to find this. So what ends up happening, we can find this distance here. All right, we can find that distance and then go from there. So this distance by using Pythagorean theorem is going to be 7.3 because this is 16.7, and then this would be x initially. So 16.7 squared minus 15 squared, and then since we know the radius is being 16.7, we know this has to be where are we at? 9.4 as your final answer. All right, similar over here. We first find this, and then we can subtract it. When we're all said and done on this one, we're gonna get an answer of 7.1. So go ahead and give that one a try and see how you do. All right, on number 13, again, we have here to here, this is gonna be a radius of 15 because the diameter is 30. So once you find this thing here, then you can subtract it from 15, and you're gonna get a value of 9.9. Number 14, same thing here. They want this distance, right? You can figure out what this is, and we get 8.4 as our value there. So a lot of Pythagorean theorem going on. You just have to figure out how to set up the equation. That's probably the most challenging part. So it does take a little bit of thinking. It's not just, here's what you have to do. So that's why this is awesome to learn, is it teaches you how to think more than anything else. All right, so now we're talking about arcs and angles. All right, so we have an intercepted arc. We divide that by 2, we get an angle of 40 degrees. All right, here we have an angle of 42, so if we multiply it by 2, we get an arc of 84 degrees. All right, down here, they want you to find this part right here. So in order to do that, we need to find some stuff. If this is 35, that means this arc right here is 70. And if we look this way, the whole thing is equal to 180 degrees. So how much of the 180 do we have? 70. So if we subtract, we get a value of 110. Coming over this way, they want this part here. Well, this is formed by this angle. And given that we have 2 angles of the triangle, we add these up and subtract from 180, we get 61, and then double it to get an arc of 122 degrees. So those are some simple arc and inscribed angle questions. All right. So now we have a couple, here's a question with a quadrilateral inscribed in a semicircle. And so keep in mind some of the properties of that. This does not go through the center, so we don't have 180 degrees in this case. But we have 4 inscribed angles in one question. We also know that opposite angles are going to add up to 180 degrees. So using this, we can figure out some of these values. So since we want this, we have to find out what this arc is or this arc. And so probably the easiest one is going to be to go like this. Because if we double 119, right, that's going to give us 120 is 140. It's going to give us 238 is going to be this entire length. That's 238. And then out of that, we have 168. So when we subtract that, we're left with, where are we at here? 70? Is that right? Yeah. 70 degrees? Yes. So this is 70 degrees. So now once we have that, we can look at, we know this is 70. We can now use this to figure out what our missing value is here. Because if that's 70, this is 65, double it will give us 130. So this means this has to equal to 60 degrees. Okay? All right, over here, they give us this arc is 95. That tells us that this whole thing is 195 plus 75. And if we subtract that from 360, we get our answer here being 95 degrees. All right, over here at number 11, they want you to find x in this case. And they have it as a variable expression, which is okay. So if this is 110, this has to be 70, okay? And in fact, this is a problem that we don't have to do on the quiz, so we will skip this. Same thing with number 12. We're not gonna have anything like this on the quiz. And that is all your problems for this review guide.